Another round of applause for Sanjay.
Cheers, thank you. Thank you, Perry, and hi, everyone. I'm Sanj, and we're going to talk about optimizing the web. I'm just going to make sure this works. Brilliant. So those colors look really nice on there, don't they? I hope you like those colors, and I hope you like the sound of my voice, because you're going to be seeing a lot of that for a long time and hearing a lot of this, okay? So I'm an engineer at Compare the Market. We're just up the road at Old Street, and we've got an office in Peterborough and somewhere else, who knows. I'd really like to thank Perry and London Web Performance for making this happen, bringing us together. That's brilliant. And the Financial Times for hosting us, and Compare the Market for paying me to code. So the web, all right, the front end, we're at a really, really interesting time, I think, with the web, or maybe you can call it a really challenging time. There's so much scope. There's so many new tools for us. There's so much we can do. And I like to draw parallels to optimization in the web with JavaScript. Now, JavaScript, I assume a lot of us are very heavily sort of focused on the front end. And JavaScript obviously dominates the front end for us, right? Now, it's got a bit of a bad reputation, right? Especially people who are kind of like not inclined to JavaScript, or they've never really learned it, or they're like backenders or database people. They will scoff all day long at JavaScript, right? And there's maybe a little bit of kind of truth to that. You know, it's been around for a long time. It's really flexible. It's the Wild West. You can do what you like. Now there's lots of sort of tools and frameworks and like monitoring systems and things like that. And there's lots of patterns and books and people to teach you how to do stuff. So there's really nice, great ways to write JavaScript, but we're not all really forced to do that yet, right? I think that really is a great parallel for like optimization. I think the web has like a really, really bad reputation, you know, and we're going to see a little bit more about that in just a minute. So why bother optimizing? Why care? Well, let's have a look. So in November 2016, mobile web usage overtook desktop for the first time in the UK, right? And around the same time, there was like a really big sea change in sort of adaptive websites, or companies with adaptive websites going to proper fully responsive websites. So adaptive, just like something that'll scale with your screen. Responsive, something that ships the same HTML, the same payload, but the CSS style stuff to give you a really nice experience on the web, right? This is what people want. So in the last year alone, the median mobile page weight has gone up 12%. That's in the last year, right? And in the last 8 years, that's only since 2010. It's not really that long ago. Mobile payloads have gone up over 9 times, 967% in the last 8 years. But in that same period, your typical mobile broadband speeds have only gone up about 4 times, from around 5 megs to around 20 megs now, right? So our payloads are getting way out of hand, right? And speeds aren't really keeping up with that. So I'm not surprised that people are a little bit kind of upset with where the web's at. So if you thought the web was crap 8 years ago, it's more than twice as bad now. So I really should not have put so much text up there. Now you're going to be reading that. So I'll give you 2 seconds. Like the gist of this basically is, by the end of this year, they're predicting that about 79% of global internet use will be on the web. The UK generally mirrors that, right? So if you're anything like us, then probably your typical user or your typical web page gets served like maybe around 60 to 70% of the time on web now. That's quite a lot, and it's going to be nearly 80% by the end of the year. Those other 2 stats there are just saying like why people like good web experiences. They won't recommend you, they won't use you, blah, blah, blah. So that is a really old CRT screen with like Pac-Man burnt into it, right? Sometimes I think of my mind like this, because I'm sitting there like programming my website. Yeah, that's what we call it, right? Programming your website. I'm doing everything on like my desktop, on like my Chrome. I've got like, a giant SSD, I've got loads of RAM, my broadband's awesome. Everything loads like super, super quick. And I'm building everything in desktop when really 60, 70% of my users are using that thing in mobile. So what am I doing here? I feel like that's burnt into my mind. Like I think of people using our website and I go, oh yeah, they're gonna get this experience. They're gonna see this. It's gonna load instantly. It's gonna be brilliant. But that's really not the case. And I think one of the challenges that we have is to try and break out of that mindset, try and simulate what's actually going on in the field. So quick, fun little quiz. Put your hand up, please, if you know what this is. Okay, excellent. You, sir?
It is Sir Tim Berners-Lee's first web page in HP 0.9.
Correct. The gentleman there said it's Tim Berners-Lee, Sir Tim Berners-Lee's first website. And it is, in fact, the very first website in the world. And it's from 1991, right? It's still live. There's a URL. I'll share these slides with everyone at the end. You can go and click off at the links and read up whatever you like afterwards. But yeah, that was 1991. That's very different to today, right? It puts things in sort of perspective, right? So now this is going back to November 2016. This is really timely coincidence. The same week that they announced that mobile web usage overtook desktop, Google came out with this saying that eventually their algorithms will use the mobile version of a site to rank pages. But at that time, it still wasn't a thing. So page speed does not affect SEO ranking. The last time I did this talk, that was still true. That was only a few months ago, right? Fast forward to now, and it's happening. As of July 2018, web payloads, web speed will affect, mobile speed will affect your SEO rankings, right? Now, I have a feeling many of you probably already know this, or you know bits and pieces of it. It's probably not news to many of you. But what does this actually mean? I mean, it doesn't mean that super optimized pages are going to go straight to the top. What Google is saying is that really it's going to be more about really poorly optimized pages going down a little bit. And they say it's going to affect something like 5 or 10% of websites. But I mean, who knows? All we know is that mobile speeds are going to start affecting SEO rankings in July of this year. So just to hammer the point home, I'm going to go via our website and hit up our car insurance journey. And let's have a look at what we're doing here. So this is, I fired up the network tab in Chrome. You're all probably very familiar with this. This is the experience I get when I'm building stuff. We see the DOM content loaded event there and the page load event. For those who are maybe not intimately familiar with that, DOM content load is like the document has finished building or whatever is needed for the page to become responsive, right? And then the second one, the page load, that's when everything has downloaded, everything is built, and you're good to go. So, I mean, for me, 0.8 seconds, DOM content load, 1.7 seconds for everything to load that page. That's pretty cool, right? No problem. Except now if I switch over to fast 3G, that DOM content load event goes up to 3.7 seconds on the same page and 7.4 seconds on the same page for page load, right? And it gets even worse. Now, in the field, people are probably going to be experiencing something a lot more like this, like a slow 3G, right? Where the DOM content load has gone up to 13 seconds and the page load has gone up to 26 seconds, right? Compare that to 0.8 and 1.7, okay? We're now at 13 and 26, right? This is on like a network throttled and CPU restricted simulated connection. That's pretty horrendous. That's probably what probably 60, 70% of my users are experiencing out there, which is really not great. And I have to say, I'm actually proud of the optimizations we've done on our site throughout many, many pages. My team alone, which is one of 15 in the company, we host about 2,000 content manageable pages. We're the gatekeepers to all of the other teams who handle like the journeys to sort of give you car insurance or home insurance or whatever it is, right? Where we sort of bring people in, right? So our pages are actually not bad. We've done a lot of optimization on it, right? We have a huge payload to work with. We've got lots of really complex systems that come together. So this is the best we can do. I'm not really too ashamed of it. But you see the problem, right? The problem is, why is optimization such an issue? Because out there in the field, people using our products and services are getting a very different experience to what we're getting. So to wrap that brief section up, why do we care about optimization? We care about discoverability. You know, how well are we ranked? How well will people find our content? We want to help them. We think we have good stuff for them to use, right? UX, users kind of expect an experience. They want life to be easy, simple, quick, and DX, the dev experience. Now, I really love best practices. You know, I like to write really good code, and I like to train and mentor my other engineers to write really, really amazing stuff. You know, I want to go in on a PR and go, boom, here you go, here's some science. You know, that'll make everything 5 times better, right? So if there's better ways to write stuff out there, I want to know about it, you know, and optimization is one part of that sort of puzzle. You know, I want to get good at it. I want to be like the master of it. You know, I want to pioneer this stuff, right? I want all of us to be, which is, I'm sure, what you feel as well, because you're here at the London Web Performance Meetup. So what we're going to talk about today, very briefly, is we're going to have a look at how the browser builds the DOM. We're going to look at our opportunities for client-side and server-side optimization. We're going to understand the concept of the fold and how a user sort of wants to work with that. We're going to look at some tools, and we're going to look at some game changers, some potentially emergent breakthrough new technology that many people probably already hate. So now, I've been doing this talk for a while, and this is what it used to look like, right? We're going to show you some like HTML and stuff. We're going to have like an example page. And then we're going to like talk about, you know, optimizing stuff and have some tags up there and stuff. And we're going to look at this thing here. Look at that. It's a critical rendering path. Wow. Whatever that is. We're going to do, my God, it's so boring. It's just like information. It's pointless. This is not fun. It's a Wednesday. You've had a whole day at work. I hope you have a beer. If anyone doesn't have a beer, please feel free to go get a beer. You know, I don't want to do this. The thought of having, when I spoke to Perry like about a month ago, and I was like, oh, cool. I haven't done this talk in a while. It'll be really fun, you know. And Stacy, my colleague, she always comes to this meetup. She said it's really cool. You should go. And I was like, oh man, I've got to do this talk again. It's so boring. It's literally gray. I mean, I don't know what I was thinking, you know. So instead of giving you another boring presentation, I want to have a little bit of fun. I want to do something a little bit more impactful. I want to engage you. I want to tell a story. I want to take risks. Simon, sir, do you take risks? Simon takes risks. That's why he's there. Okay, so I just want to have a little bit of fun. I want us all to learn something, and I want this to be a safe space for us to all explore performance optimization. Okay, so I'm not going to give you optimizing the web. All right, I'm going to give you optimizing the web like it was dating. Okay, now who here is still dating? 1, 2, 3, 4. Simon? 5? Okay, that's at least 5. At least 5. All right. Who should be dating but isn't? God, Simon, you can't put your hand up twice. Okay, a lot of people should be dating, but they're not, right? Who's dating but shouldn't be? Who's dating but shouldn't be? Simon! 3 out of 3, kid! All right, okay. So, why I think the web and dating are going to make really good bedfellows and help us really, that is not a pun, that is not a pun, and really going to help us to sort of play in this area and explore a little bit, right, is because the web and dating both have lots of issues, okay? So I'm going to walk through a typical date of mine, all right? They're all bad, okay? So this is me, all right? I know what you're thinking, right? That guy looks a lot better, right? I made myself a little skinnier, you know, gave myself bigger muscles, right? It's my presentation, so I want to have a bit of fun, okay? So here's me. Here's a partner who I like. This is someone who I'm attracted to, right? You can play along with me, okay? Put yourself in my place, and this is whoever you're attracted to, all right? So I really like this person because, you know, she's kind of like, you know, she's got a little scar and, you know, she's got a little neck tattoo. She's got like 3 earrings and like 1 ear, but it's okay. You know, she got a little dimple or something, you know, and I'm just kind of attracted to it, you know. She does it for me, you know. What can we say? So great. I liked her. She liked me, and it's a match. All right. So great. We get it on. We send a message. No, we don't get it on. We strike up a conversation. Okay. Get your mind to the gutters, please. All right. Okay. So
I'd just like to say I used to work for UDate and Match.com, and we never thought of this. It would have been a good concept. There you go. I might feed it back to some ex-colleagues.
Please do. Yeah. If you need any, I'm available to contract if you want. So here is where our first problem begins. Okay. I turn up looking like this. Okay. I'm a bold person. I like to take risks. Simon knows that. Okay. I think, you know what? Maybe this is stylish, right? Maybe this will like set me out from the crowd. Okay. So she comes along, she meets me, she goes, uh-oh, what's this? Okay. Let's break down what's going on in her mind. Okay, let's try and understand. She sees my head. Okay, great. She goes, cool. I'm building a picture of this guy. Who is this guy? Right? She goes, cool. That's a head. That's nice. No problem. Right? What's what I expect? Uh-oh. There's a style tag. All right. That's a red neckerchief. Okay. I went with this. Yeah. I don't know why. So she goes, okay, hold on. That's a bold move, right? I'm going to have to store that for later, right? That's what this guy looks like, okay? And she keeps processing me. She goes, cool, that's the end of the head. Now, here we have the body beginning. Cool, you know, that's great. Head and a body, that's what everyone needs, right? That's the bare minimum. We all know that, okay? It's all you need, okay? And then she keeps going down. And then she goes, uh-oh, that belt, all right? Let's imagine that really gaudy 90s rock star studded kind of belt is like a script tag. Now, in her mind, what this says is, whoa, hold on. This is beyond just the style. This is something special. I've got to now go back and contemplate what else is being presented here to me, right? This script tag is blocking my perception of this person, okay? It could, thank you, yes. This script tag could have really big implications because on its own, it's one thing, but now combine that with that neckerchief, what is going on here? What's the statement? What's this person trying to say? You know, but okay, she's a nice person. She thinks, okay, never mind. Maybe I'll give him a chance anyway, right? So that's what's gone on in her mind. Now let's draw a parallel between that and what goes on in the browser. Okay, so the browser receives our payload. Yeah, it comes to our page. It goes, let me go to this page, .com. Our server or CDN or whatever, sends it a payload. Right? It receives the payload. It's HTML. It starts to parse that. Yeah, it takes that and tries to break that down into a language it understands, which is actually the, do I have that? I'll have that. I'll have a link for you later. So it takes the HTML and breaks that down into little nodes. So first it starts to build the DOM, the document object model. That's what, you know, commonly you can sort of think of that as your regular sort of HTML that you write, okay? And then it goes, okay, great, HTML. And then boom, it hits any form of sort of styling, style tag, internal, external, inline. And then it goes, great, now I've got to start to build the CSS object model. These are like the set of rules of how all those DOM nodes look. So it can combine them together, right? And then it keeps going further down the page. And it eventually hits a script. Now, it then has to stop everything it's doing and finish downloading and parsing and building the scripts, because it could have an impact on the DOM and the CSS object model, right? Once it's done all that, sorry, I'm just going to open this water. Oh, really thirsty. So once it's got all those, it's got all the nodes it needs to build the page, and it can build a render tree. So render tree is like the final process of sort of compiling and computing stuff. And that is essentially like a blueprint of how to build a page. Yeah. So in its own language, it knows I have all the nodes now to build this page. So it then proceeds on to the layout phase. Now, layout is when it takes all those nodes and it sort of decides where I'm going to put everything. Everything is a square or a rectangle as far as it's concerned. It decides, where am I going to put this thing? How big is it? What is its width and its height? That's all it's doing. And then it goes into the final stage, which is the paint stage. Now, at this point, it knows where everything is, what everything is, and it literally is just rasterizing the pixels on your screen, whatever the output device is. You'll be very familiar with that if you've ever worked in like design. So let's have a quick look at what our DOM looks like. So this is that simple page we'd be building. It's just a collection of nodes that will help it build a page. Now, that link in the bottom is the HTML5 DOM specification, which that's brilliant. Like once you get like to like matrix levels of like knowledge, and like when you've had so much fun playing with HTML, and you really have to know all its deepest, darkest secrets, how it's built, what's the blueprint and everything, you go to the HTML5 DOM specification, which is like encyclopedias of like knowledge. So we see that here we've got our HTML, we started building our head, we've got a title, a meta tag, or few, then it hits a link, a style tag, and it goes, cool, I got to stop building the DOM now, and I got to worry about the CSS object model, right? So the CSS object model is, well, CSS is just a dynamic set of rules, is all it is. It's like rules of how to style certain selectors, right? So CSS is actually render blocking. Now, we're going to see something on the next slide that talks about what JavaScript does. So just remember that it's render blocking, and these terms are going to be used interchangeably a little bit. And the thing is, it's render blocking because the browser will refuse to continue building or display anything until it can fully build this CSS object model at this point, because it needs to know what stuff looks like. So that's generally why you would put CSS in the head as just a very like sort of starting kind of rule, right? You want to do that because you don't want your raw HTML to be shipped and to actually display on the page. Well, you probably don't until it's being styled, because that might be a little bit embarrassing. And you might get that flash of unstyled content where the DOM displays The user sees it, and then the CSS kicked in, and boom. So that's why it usually goes in the head. CSS can come in many forms: external, internal, inline. There are examples of all three. As far as the browser is concerned, as far as I know, it handles them all virtually the same way, but there are differences in how it computes and executes those nodes, and we'll talk about that later. So JavaScript, as opposed to being render blocking, is parser blocking. So render blocking is the browser will not display it. Yeah. Parser blocking is the browser will stop everything it's doing and compute all of the DOM prior to that script, and it'll compute all of the CSS object model prior to that script, because that script could interact and manipulate the DOM and the CSS object model. So the browser wants to be sure of what it has so that that script can reliably act on what's come before it. So we see here an example of the DOM nodes that could have been built and the CSS object nodes that could have been built combined into one, and then we have those two little additions that our JavaScript has made and attaches them to the same nodes. JavaScript, like CSS, can be external or internal. You can also have inline JavaScript, which maybe some of us have written, but it's really a bad idea. It's really unmaintainable. It's extremely weighty and really needy on the browser. So you don't want to, please don't use inline JavaScript. You know that already, I'm pretty sure. So now at this point, we've got our render tree. So the browser knows, cool, these are all my nodes. This is the DOM, the CSS OM. I've enacted the script on the DOM, and I know everything I need to build this page, right? And then next it goes to the layout phase, where it decides where all of those nodes are going to go, how big they're going to be. And last but not least, it paints them. It rasterizes those pixels on our screen. So let's start talking a little bit about optimization. So as a general rule, you want to minify everything. You definitely want to minify your HTML. Typically, just by minifying your HTML, you might see something like a 50 to 60% decrease in payload weight. That makes a huge difference. You want to compress as well. Again, that can typically give you anywhere between a 40 and 60% improvement. These are numbers I'm pulling out of, they're averages. As a typical example, if you minified and compressed Bootstrap, you would have something like a 90% overall weight saving, which is really not negligible, right? We're also going to look at preload, prefetch, pre-render, and pre-connect in just a moment. Does anyone have any experience of any of those four? Okay, great. Few people, brilliant. So before we do that, I know you must all be a little bit bored, so let's get back to our date, okay? This is what's going on. So we've gone into the restaurant. We're having a nice meal, and my friend here asked me, "So what have you been up to?" Right? I'm prepared for this moment because I'm a good date, right? I know that obviously she's gonna want to know what's going on, what's happening. I'm prepared. I've pre-fetched all that information in my mind. It's ready to go. It's ready to go. Don't laugh. Right? So I know. I'm prepared for this. I know where she's coming from. She thinks she has me beat. I've been on 6+ dates. So preload. Preload is the outlier of those four. Preload acts on your current navigation. That means on the actual page that your user is on. And it bypasses browser prioritization. So your browser will intelligently prioritize the loading of resources and links and things like that. But what might happen, for example, as happened with us maybe about 6 months ago on a little React project we were working on, where there's an element that's hidden until the user clicks on a certain button. Now, when they click on that button, the element shows, and then the browser decides to start loading that image. And by that point, it's too late, because you know, I don't want my user to see like nothing and then an image slowly load up, right? So in that case, we could use preload to say, you know what, you're going to need this very soon. So why don't you start preloading it? And this can even help by preloading really important resources or links at the very top of your page in the head somewhere. So by the time the browser gets to the bottom of the page where you may be using them, it's already had some awareness that it needs to preload them. We might be saving milliseconds or a tenth of a second, but it's all worth it. So now she wants to ask me, any plans for the weekend, right? So I think I know what she wants to know a little bit about me, right? She wants to know about my future, yeah? She wants to know about what's coming up. Maybe she wants to have a think about what we could do, you know, what are my interests, you know? Now, I obviously want to look good, so I'm going to tell her, you know, I'm volunteering at the RSPCA, you know, going to the gym 6 times. I'm going to do all sorts of amazing stuff, but I'm actually not going to the gym anytime, you know, so, you know. But you don't want to make like wild promises, like, you know, yeah, you know, I'm going to go skiing and stuff, because then she may want to go skiing and discover I've never skied in my life. That would be really embarrassing. So these are about future navigations, okay? So one of the attributes we can use is prefetch. Now, there's 2 flavors of prefetch. You can prefetch resources, and you can do DNS prefetches. So prefetch is for future navigations, not the page the user is currently on, but you're predicting that they're going to do this next, and they will probably need this image or this font or this script, or they may want to connect to this CDN or this other site or this other page in our journey, which is on a different domain. So you can perform a DNS prefetch where it does that very first stage of DNS connecting, where it goes, I know what it's called, but what is the actual address? It'll sort of look that up, and it'll cache that locally. Then you have pre-connect. Now, pre-connect goes sort of like a couple of steps further. It does the DNS, the TLS, and the TCP handshake, which is a lot of what you'll sort of need, or your users will need, to sort of make a connection. This is pretty useful. Just be careful with these. I've got a link up here on the first 2 pages for you to go check out. Some of these have limited support in certain browsers, but we use these extensively, and they're useful for where they work. Pre-connect. Now, this is the big daddy. No, sorry, this is not the big daddy. That's the next one. Pre-render. This is the big daddy. Now, this is where it will actually fully render a page in the background. This is a really, really heavyweight operation. You want to be sure about this, because you're going to be using a bandwidth. You're going to be slowing down that main thread in their browser. So be a little bit careful. Pre-connect. This is the slide we were looking at before. Pre-connect happens to probably all of us many, many, many times a day. If you use Google Chrome, it will try to predict based on your past navigations, based on what you've done. It'll try to assess what, as you're typing, what you're likely to go to, and it will try to pre-connect you to those to make them a little bit quicker. So CSS and JavaScript, one of the main sort of things we're going to talk about is timing. It's all about when to give what to make things work well. So if we go back to our date, right? Like, imagine you're there with your partner. You ask the waiter, you put your order in, you say, yeah, we'd like some drinks. We'd like these starters and this main and maybe this dessert or something, maybe a little coffee and whiskey for afterwards. He goes, great, that's brilliant. And then like an hour goes by nothing comes, you get nothing, and then you get all this, everything all at once. You don't want every single thing you ordered at the end of your meal to turn up all at once. This is completely counterproductive. It's counterintuitive, and this is what's sort of happening on the web. These are the things we want to optimize against. And at this point, it's probably a good idea to introduce the concept of the fold. So again, I'm not ashamed to say this is one of our pages. It's a well-performing page. We have lots of challenges. So this is what you would see in a typical like small mobile screen. And that on the right is the entire page as would be displayed on a small mobile screen, okay? So you could think of that as sort of the fold. That's above the fold. That's what people will first interact with. That's what you should say, here you go, here's your starter, right? And then while they're looking at that, maybe they're scrolling around a little, they're tapping on stuff, you can be preparing the rest of the meal in the background. You can be shipping it down little by little to give everything what they need, to give everyone what they need when they need it. So CSS, how do we optimize CSS? One of the ways is with media queries and attributes. Like we've almost certainly all used these before. You can use them within your tags as attributes, and you can use them within actual internal style tags as well. Media queries and media attributes will not stop those things from downloading, but it will defer them to off main thread. It'll put them as low priority, and they won't block anything else. So unfortunately, it's not a great fix. It's the best we have. So typically what you could do if you're building mobile first, you should really say everyone gets the mobile style. And then you could put a media query on like a desktop or tablet style. And that way, mobiles or tablets may be forced to download it, but it won't be blocking anything, you know? Critical CSS, there's two things that I'm going to promise you work great, and this is one of them. So that is deferring the loading of critical CSS. Now, we use a package here from the Filament group called Load CSS. Let me maybe just run through this really small bit of code first, sort of explain what it's doing. So at the very top there, we've got our site-wide CSS. And we're preloading this. So we're saying, don't block the page or anything yet. Just preload this, and later on, soon, we're going to want you to do something with it. And then below that is where we inline our critical CSS. So we are writing out all of our critical above the fold CSS in that portion there. And it's being shipped down with our HTML payload. It's written on the page. And then below that, we have a no script tag. So if anyone can't use JavaScript to defer the loading of that CSS, then they can just get the full site-wide CSS. And then at the very bottom, we use our, we call it the async JS, but that is the load CSS package. And what that does is with a little bit of, tiny bit of setup, that will then go in and take that preloaded site-wide CSS and append it to your entire page, right? Now, I think at this point, this is an old screenshot, by the way. I think at this point, our site-wide CSS was something like maybe half a meg or something like that, pretty big. We have a lot of pages to support. And our critical above the fold CSS was something like, I don't know, about 150K or something. Now, we added an extra 150K of page weight straight into the HTML in the DOM. If you looked at it on like a wide screen, it'd be about this much code, okay? That is a lot of code. And we haven't stopped our site-wide CSS actually downloading. All we've done is we've deferred it. So we've said, don't stop anything, don't block the main thread, download it in the background, and once you're done, we'll let you work, we'll let you do your thing. That one change was probably our single biggest win in terms of page speed. At this point in time, we had pretty mediocre page speeds, and we got about a 20-point boost from this one thing, So if you're not doing it, I would really, really suggest you investigate it at least. Go in with an open mind and see what it does for you. And this package, Load CSS, works really, really great for us. I could wholeheartedly recommend it. Basic thing, less specificity. At the top there, you've got like a chain selector there with the style rule, and then below it, we've gone and we've just given it the most simple sort of selector we could give it to give it the same style rules. There's like an obvious benefit here. It's less bandwidth. Instead of like, I don't know, 20 characters making up your selector, it's only like 5. It's also less computational drain. Less complex selectors take less CPU. CSS, write it good. It's easy to say. Only deliver what you need. Also, very easy to say. If you've worked on the front end for any length of time, you'll know it's really scary to delete CSS because it's really hard to know what it's about to break. So you wanna make it easy to delete. However you can modularize it or compartmentalize it or set yourself up now in the present to have a better time getting rid of it in the future, put that time in. It'll pay off. Mangling and minifying names. This is something we're experiencing right now ourselves on our team because we're setting really, really strict limits to the size of CSS that we can build. And actually, we're fast approaching that just because we have really nice selector names, you know? Something, dot something, dash something reads beautifully. It's so immediately apparent what you're styling, what you're doing. Unfortunately, that's all bloating our DOM. So we've gone down to slightly more mangled, smaller class names. One of the cool things you can do is you could use some kind of a pre or post processor to do all that for you. So you can write your really nice, beautiful CSS. You can put in all the lovely class names and selectors you like. It'll do its thing, make everything really small and tidy. It'll name things like A-X, whatever that means. And it'll give you like a source map that you can then use to sort of, in production, locate where your original style rules came from. So the UnCSS package, a lot of you might be familiar with this. This is a really simple thing to sort of say, go test this page, and it will decide, based on what's actually on the page, what CSS you do and don't need. We looked at trying to get this into our build process, our CI at one point. We experienced some issues, but I don't think it's insurmountable. It depends on the complexity of website that you're building. One of many tools out there. So we have options. JavaScript, the async property. Let me see if I can point that out to you. Right there, that little async tag right there. This is a way of deferring or taking your JavaScript and not letting it block the main thread. What this does here, if we have a look at this thing here, so if we go from left to right as the DOM loads, we can see one script is loading here, the other script is loading there. If they were both async, this one could start loading and take ages. This one could start loading and download, compute, and execute here. This one could do it here. Essentially, we're saying act asynchronously, download when you can, do your stuff when you can, and it removes it, again, from the main thread, so it doesn't block anything. It's really, really useful. We use it a lot. If you want a little bit more control, you could use the defer tag, or attribute, should I say? Is it attribute? I think it's attribute. Defer does something slightly different. Defer will say you will execute in order of appearance and only after the page is loaded. So it gives you a little bit more assurance that this deferred tag will wait until the page is loaded and everything's there, and then it'll do its thing. And all the meanwhile, it's not blocking our main thread. It's not blocking the DOM loading. It's not blocking the page displaying and becoming responsive. if we want to go, so at this point, we're sort of at this link or tag stage where we're deferring or asyncing how that script gets downloaded into the browser. Now, you could go one level deeper and say, okay, you can download, you can parse, and you can compute, but don't execute yet. Use something like an onload, or in the jQuery world, something like a document.ready. That's just to say, don't do your stuff yet. Just wait for an event, a click, an intersection observer, or even just the page load event. DOM operations are expensive indeed. We saw that tree before where we had the DOM, the CSS OM, then we have our scripts and the render tree, the layout, and the paint. Every time our JavaScript acts on that, it has to go through those steps again. This all takes time. It takes milliseconds, which all add up to many seconds. Don't write markup as strings. You should really use native methods. This is because the browser, again, has to take that string and break it down into a language that it can understand as JavaScript. So it'll get the string. It'll recognize it's a string. Then it'll recognize that this is a string that represents JavaScript. So now I've got to do an additional translation step. Write code good. It's easy to say. But of course, writing cleaner, smaller, more performant code with like a minimal footprint, this all makes a big, big, big difference. I just want to point one thing out. This is something that stuck with me for a while. This only happened like a month ago, right? I can see my colleague smiling already. So this was like, I put in Stacy and one of our other engineers, Ginevra, they were working on a block. I went in there and I had a look at some of the code, and they were using this thing down here where they're doing document.getElement by class name, and then the selector, and then the first element in that array, right? And I was going, I've not seen that before. That's a little bit long. That's a little bit weird. Why don't you just use like document.query selector? Have you not heard of it or something? And I actually had to get educated. So Ginevra spoke to Stacy, who then replied to me on GitHub and said, actually, Ginevra has found that that method is a more performant way of locating that one element. And indeed it is. It says so on JS-Perf, excellent website, we should all go read. And my point there, I guess, is that there's lots of like little surprises out there, and there's lots of little tricks to like little JavaScript and stuff, you know, and they're like tiny little gains that all add up in the end. I kind of want to mention a little bit about ES6, its prototypical inheritance. So we all know that. Oh, good. So we all know that if you're writing like ES5, you're probably writing functions, or you're building pseudo-building classes that will then make use of prototypical inheritance. So you're not constantly instantiating the same methods over and over on your class. So you use prototypical methods to sort of say, I only have one copy of this method or something. Now, the really nice thing about ES6 is that if you use ES6's sort of class syntax, it does all that for you. So you just say class something, open curlies, start writing your constructor, then your functions. Behind the scene, ES6 is doing something really, really smart and constructing all that prototypical inheritance for you. So you don't have to worry about it. It's bedtime. Someone wave your hands. All right, sweet. Okay. That's the best thing that's ever happened to me at a meetup. Okay. Functional programming versus object-oriented programming. I'm not going to get into like any kind of debate. I'm not here to sort of say this is good or this is bad, this is the right way. Ultimately, I think you should write what your engineers are most comfortable with writing and maintaining. But there's a growing movement out there because JavaScript is a multi-paradigm language. You can write it OO, you can write it functional if you like. You can even just write it interpretively, right? And the nice thing about functional programming is Well, the not so nice thing is that it's a little bit tricky. It takes a little while to get good at it. You've got to keep at it. You've got to have people who can give you reviews and sort of teach you how to do it better. But it's kind of quite nice. It's pure functions. It's things that don't have to have any side effects on anything outside of their scope. I'm not going to be able to do it justice right now, but there are lots of performance gains to be had by using a bit of functional programming, if you can, or even mixing the two. It's not really a problem as far as I'm concerned. So performance monitoring of methods. This was I worked on an open source ticket a while ago, and one of the tasks there was the head engineer had said, can you also please see if you can figure out which native method is quicker than the other, if we can replace matches with closest. So I came up with this really tiny little repo that just sort of builds a page with lots and lots of elements and lets you execute certain methods on it and just see how long they take. And I found that to be really, really eye-opening and a shift in how I think about stuff. When I see stuff now, the next time I copy and paste from Stack Overflow, I think to myself, like, is this really the best way? Can I just spend like 5 minutes like looking it up? Can I do a quick test myself and see if there's anything better out there? There's a link down there if you want to go check it out, by the way. Big O, computer science. Any CS grads here? It's okay. Don't be ashamed. I'm not gonna talk to you. I'm not gonna talk to you. How dare you? No, I'm only kidding. I wish, if I could go back in time, I wish I did a CS degree. Unfortunately, I didn't. But I've been reading this book called The Imposter's Handbook, which has been really highly rated and recommended to me by many people that I respect in the past. And I love it. It's brilliant. It's from a guy who is a self-taught developer. And he wrote this book for other self-taught developers or other bootcamp graduates who haven't had the pleasure of getting a formal CS degree and learning all this theory and all these algorithms and stuff. And it's really, really brilliant. I really recommend you give it a read. The first few chapters are free. And one of the most impactful things I've read in there recently is about big O, sort of algorithms and optimizing things. These are the kind of things that they'll ask you if you ever go do like a Google whiteboard interview or a Facebook whiteboard interview. So big O, what does that mean? O is like order of complexity. It's sort of a way of figuring out this method I'm trying to run. What is the theoretical maximum amount of time and space it will take to do its thing? So if we have a look, let's say our function or method takes an array of n number of objects, okay? That blue line at the very bottom, that's constant time. Now, if that function always, for example, returned the first element or the last element or a certain value, that means regardless of the size of that data set, you're always going to get the same output. It's always one operation. The amount of time and space it takes that function to perform that calculation is always the same. So that blue line remains flat. No matter how many number of inputs we give it, it's going to always take the same amount of time to give you your return. If we have a look at the green one there in the middle, that is, let's say it has to loop over each one of those elements one time. That means as time goes on, the amount of time and space it takes that function to return you something is going to grow linearly. If we look at that yellow one in the top left, that is if you had a data set and you need to do a nested loop. So you have X number of objects, and within those, you want to then iterate a further X number of times. You want to nest, and this grows very, very steep, very exponentially. This will go sky high right away. I write so many nested loops. I write so many double, triple nested loops. I think I have a loop that recursively goes back on itself 5 times. It's ridiculous, and I can't wait until the next time I get to work on that piece of code so I can make it better. Because right now it's like what it takes a computer to build that little bit of code is probably more than what it took to go to the moon like 30 years ago. So log n is something really, really, really interesting. This is saying the order of magnitude is logarithm n. If you're not like a big maths person, that's cool. Neither am I. I'm going to explain it to you. That is this red line. So that's saying if you had to do that same number of nested computations on something, the same as that yellow line, if you simply halve your problem at every stage, just divide it in half, you have to be very creative in how you're running your algorithm and what you're getting out of it. But if you can actually achieve an order logarithmic n, then that yellow line will become that red line. That is a massive performance gain. Now, to ram the point home even more, let's have a look at this. So we've got 1,000 iterations, 1,000,000 iterations, and then 1,000,000,000 iterations. Now, on the left, we have our constant. It always just gives you the first or the last or whatever, always return true. The time stays the same. It's 10 nanoseconds for each operation, regardless of how many points of data you have in that data set. The one on the right, yes, you're right, is the linear one. This is the one that grows linear in relation to the amount of data that you have. So if you had 1,000 bits of data, it would take 10 nanoseconds. If you had 1,000,000, it would take 10 milliseconds. If you had 1,000,000,000, it would take 10 seconds. Now compare that to our nested loop, which is the one on the far right here. This is your quadratic. This goes from 10 milliseconds to 3 hours to 300 years to recursively loop over 1,000,000,000 points of data. If you can apply the log n algorithmic way of solving the same problem, you halve the complexity. And what that actually means is every time the number of the data points goes up 10 times, you're actually only adding the same constant finite amount of time onto the end of what you're doing, which goes basically if we're looping over 1,000,000,000 points of data, we're doing a nested loop. Instead of 300 years, you can do it in 300 nanoseconds, which is, or milliseconds, I think that's supposed to be, sorry. That's like a massive, massive, massive saving. I can't really do it justice here, but there's a link there. Please go read it. It will prove that data. So let's go back to our date. I know you're probably all like super, super bored. Okay, so we're in a date. It's like we're waiting for our food. It's going to take an hour. It's not going to be here for ages. I'm like waffling on and on. Yeah, you know, yeah, I did go scuba diving once, and I didn't actually go scuba diving once. That's what I'm going to say. Yeah, and I really like this, and I can't remember what I'm saying. I can't remember what she asked me. All I know is I'm filling time. I'm trying to get to a point. I'm trying to read her face. She's not giving anything away. And I goes, so what's your favorite sea turtle? I'm just like saying stuff all over and over and over, but I'm not actually saying anything. She's like, just like, for heaven's sake, just say something. Christ, make a point. To me, this is sort of like fonts downloading, okay? Fonts are really, really big. They're really, really heavy. They really slow things down. So you've got generally 2 sort of flavors of fonts. You've got your system fonts. These are fonts that are installed on everyone's system. They're sort of safe to use. And then you've got your own custom fonts. These could be like whatever special fonts you want your pretty beautiful website to display. That's all good. But the problem is that custom font is going to take a long time to download and a long time to process. And in the meantime, if you don't have a fallback, so you should always have a fallback. So your custom font could be whatever, financialtimes.wath. Is that what it's called, Simon? No? Okay, great. You could use that, and that's fine. But you probably want to have like a safe fallback first. You probably want a system font, because if you said do not display financialtimes.com until financialtimes.waf has downloaded, then your user is not going to see anything. They're going to see maybe a bit of a page, like a header. They're going to see like an image, and then lots of blank space. That's the FOIT. That's your invisible text. There's nothing there. And then your font downloads and it computes, and then suddenly the text pops up. We've all probably seen this before. It's kind of, okay, it's fine. You might be able to live with it, but it doesn't look great. So fonts can be cached, but obviously not the first time someone visits your page. We did some work on our font maybe around 4, 5, 6 months ago or something, and it was really sort of prophetic how timing sort of worked out, because one of our engineers, Brian, he sort of did this really detailed analysis of what the best way to do it is. We want to ship custom fonts, but we also don't want a flash of invisible text, and we don't want to unnecessarily stop the page loading and becoming responsive. So he came up with a strategy which was really great. And then like literally a day later, I saw this post on Reddit about eBay's font loading strategy. So I've linked it here because I think it's great. They do a really good job explaining it. And I guess the gist of it is, let your page download and display with a regular system font or whatever suitable fallback these people have available. And then in the background, safely download this custom font that eBay wants to use, and then cache it. So then on the next visit, I mean, the difference is like really imperceptible. It's like really tiny. But on the next visit, they will have that cached font. So they don't have to go through that whole rigmarole again. And then developers happy, the company's happy, users happy. They don't have to wait ages and ages for a font to download. Again, the link is there. It's a good read. So we're back at our date, back at dinner. You can see by those expressions, it's not really going great, I think. But I'm a really hopeful and positive person. So I think, maybe I can save this. The fonts didn't work so well. I did not do a good job optimizing those fonts. All right. But I know how I can win her over. I'm going to show her some memes. Who doesn't love memes? Am I right? If this won't impress my date, I don't know what will. So I show her this guy. Brilliant. It's a classic. Adorable. Hey? Edgy. Right? Right? Boom. Mic drop. I'm out. This is the killer, right? Success kid. She's gonna love this. But unfortunately, she didn't. Yeah, I didn't do very well there presenting those images. But maybe we can do a little bit better in the browser presenting our images. So images are more than 50% of your typical page weight these days. Images have really, really skyrocketed. Your typical page, mobile page size is now 1.5 meg. Over 750K of that is going to be images, which is a lot of images. That is a lot of payload. So how can we optimize those images? Assuming those images are pixel-based, like JPEGs or PNGs or whatever, you could go to SVG if that suits your needs. Depends on your application. SVG works great in certain places, not so great in others. SVG, of course, scalable vector graphics, which means it's just a set of coordinates for the computer to know how to display an image, and it will maintain the same size regardless of how small or how big it is, which is why they're a really, really good choice. They're usually very tiny. You want to get the right dimensions, not only on your actual physical image, which is very important because you don't want to ship like a 10,000 pixel wide image to display in like a 1,000 pixel wide div somewhere, right? That's ridiculous. And also, as a little bit of an aside, the browser really likes it if you tell it how big an image is going to be ahead of time, because it sort of helps it understand how to lay things out a lot better. And that is going to be a little bit important at the end. We'll come to that in a minute. You might want to use next-gen formats, things like, what's it called? WebP or JP2000, whatever it's called. Those things are much newer. They're really lightweight. They're a lot more optimized. They still give you all the flexibility and freedom of any pixel-based data format. Compressing those images, that's really, really, really important. So you've got your image, you've got it to the right dimensions, but it's still really, really heavy in weight. It's got lots of layers of color data there and luminosity and whatever else. You can compress that a lot without losing very much actual quality, the way that the human eye can perceive it. You have options. You could do that manually if you want. You could build it into your pipeline process. You could and probably should use something like TinyPNG or Kraken. You should be thinking about lazy loading your images. You should be thinking about the above the fold and below the fold. Images that are appearing below the fold really have no business to stop the page loading. They should be low, low, low priority. Less of them, that's always good. I always try and stop myself from saying less of anything, because that's a great solution to every problem. But really, like, being a skilled developer is about saying, okay, that's cool. You want all that. Let me tell you how to get that like right and light and everything. But if you can, less of them is good as well. There's like various studies out there to say like the best performing websites have like 3.5 images on average or something. As a rule, I don't know. There is a lot to be said about images, and these two people here, Ilya Grigorik and Adi Osmani, legends in the field of browser optimization. They've got 2 really, really good resources out there if you want to learn more about images. If you read those 2 links, you'll know probably everything you would ever want to know about images. And images are the thing that I probably get asked the most about. Like, whenever I do this talk, there'll always be a question about images. They are a massive burden on a page. Probably business interests want us to like load lots and lots of images. People think, oh yeah, people want an image there and here and there and everywhere. So we have a lot of problems dealing with them. And it's pretty easy to educate ourselves. There's lots and lots of ways of minimizing that impact. So I've shown you those memes. I didn't do as well as our browser optimized page did. I don't think she was that impressed. So I went home. It's cool. I chilled. I went to bed. I woke up the next day. I had 2.5 donuts for breakfast, right? Like a champion, and I'm feeling good again, all right? I've got a sugar high, and I'm a winner. So I call her up. I go, hey, what's going on? She goes, who dis? Now, forget that she said who dis. Yeah. Okay, fine, whatever. Maybe she doesn't know who I am. I'll forgive it. But why does she not have my phone number saved on her phone? I mean, you know, that's not a good sign, right? They say, well, it's Sanj. Sanj who? This is an even worse sign, because we just had dinner last night. How many Sanjas have you like been out with recently? You know? Why does she not? My number's not saved on her phone. She doesn't even remember who I am. This is like caching, right? Not having saved my number in her phone is like server-side caching. That hardware doesn't remember who I am. Not even remembering my voice or name, that's like client-side caching. You know, in her temporary RAM, she's still not stored who I am. These are not good signs. So let's have a look at how caching could work. if at the top we have our browser and at the bottom we have our server, the browser is making requests to the server, and in this diagram, the server is just sort of building the page, shipping it back to the browser. Now, there's no caching here. This is really unoptimized. If you get 1 million hits a day, that server is going to build 1 million pages a day. That's not good. So you can introduce a cache layer there, server-side caching, just above your server. The effect of this would be, I suppose, that that cache layer stores the pages that your server has been building so that the next time the browser requests it, it can just give it the cached version. Similarly, in the browser, you can enable client-side caching, where I'm sure you're all very familiar with this. You can set expiry dates to your JavaScript and CSS and whatever else. There's one more step we can do. We could do like a bit of memoization. This is like caching your code that lives below your pages. So whatever functions are going on, whatever data has to be processed, whatever statements have to be called, even they can be cached. They can be memoized somewhere on your server, and that gives you even greater gains. It's not that hard to do. It's pretty fun. If you're a back-end person, then you're going to have a great time. Cache busting. Now, this is a problem. Before you go caching everything, making everything last forever, think about how you're going to bust that cache, because at some point, that 1-year expiry date in your JavaScript is going to have to be null and void when you've changed your JavaScript and you need your users to have like the latest version of your JavaScript. So networking and the critical rendering path. I'm not going to go into detail about this, only because I guess I found it to be an interesting concept and something that's really applicable, but I haven't yet in the last couple of years actually say, oh yeah, wow, the critical rendering path really saved my butt on this one, or like this really illuminated me. But it's something that we should maybe be aware of. This is when you maybe feel more comfortable with all the other stuff. This is the next level. The critical rendering path basically means, if we break that down, is what is critical to that page loading, right? What is critical to that page rendering? What are the number of requests that have to be made? What is the size of those requests? What do I have to do when I get those back? How am I going to build the DOM, the CSSOM? How am I going to execute those scripts and present the page to the user? And there are a couple of complications here. One, there is the HTTP1 limit, and then there is the TCP packet loss limit. Now, HTTP1 limit, that basically says you can only have 6 concurrent files downloading from any domain at any given time. So if you have like 50 files and assets and whatever all coming off your one domain, those will all have to get into like an orderly queue. And the same thing with the TCP limit. That is basically something that's been around for many years now, and it's to stop packet loss, so that a server can't just continually keep chucking data down the pipes at you willy-nilly without you sort of responding to that or acknowledging that, cool, I received this, you can send the next bunch, you can send the next bunch. And that's at roughly 14 to 16 kilobytes. These are the 2 constraining factors that we have. Like I say, I really don't want to go too much into it, but if you want to find out more, then go look it up. It's not bad, it's pretty cool. There is also this book called High Performance Browser Networking from Ilya Grigorik. This is a great book to read about optimizing, and it's very much more focused on the networking side of things if you want to get more familiar with that kind of thing. Slide missing, do a joke about tools. So let's say you wanted someone to be able to like help you out. Let's say you're not very good at dating. You need like an assistant. You need like a Cyrano de Bergerac or whatever, you know, someone there to be whispering into your ear, this is the right way to do things. That's maybe a little bit like a tool. So let's look at a few of the tools that we have available to us. These are ones that we use. PageSpeed Insights. This is awesome. I think some of our guys went to a Google hackathon about 6 months ago, and they were talking to these Google devs about Google's own analysis tools and some of the shortcomings with them. And even the Google guys said, we really like PageSpeed Insights. We also like web page speed test. I think I've got it in here. Something like that, web page speed test. Yeah, it's really a mouthful, but they're both really, really great. And the really great thing about PageSpeed Insights is it will tell you how to best optimize your page. And one of the really cool things is it will tell you these images are really poorly compressed. You've got the wrong dimensions. They are not compressed. And then it will do that compression for you and provide you with a link to download the right image to use. It couldn't get any easier. And it's got lots and lots and lots of other really useful goodness in there as well. Chrome, brilliant. Chrome's devs tools are like such a lifesaver. I spent all my life in this thing. The network panel, really, really useful to understand what's going on, what's being downloaded. Examine headers on stuff. Toggle your speed here to see what people are actually seeing in the field. Put it down to fast 3G, slow 3G. See how people are actually experiencing your site out there. Lighthouse. Lighthouse is now built into Chrome. It's also got a standalone. It's got like a CLI, a node package, all that sort of stuff. It's also open source. It's very cool. It's very easy to understand and contribute to. Lighthouse, I think in the last month or so, added this latest tab down here, the SEO tab, right? They had performance, best practices, PWA, accessibility. Now we've got SEO as well. They're sending us messages all the time. They're telling us what they're examining, what they're helping you optimize, because almost certainly in the future, they're going to start having some kind of bias towards those things. I wouldn't be at all surprised in the future if accessibility and PWA-ness become as important as performance or best practices. And for sure, we know that SEO is going to change in July. Mobile page speeds are going to start weighing on things. So the nice people at Google have given us this SEO tab. Really, really useful. And you get so many insights out of this audits tab. Here is that same page we were looking at. Here is our report. Here's our Slack channel. I'm sure we definitely didn't invent this. A lot of people I know already do something very, very similar. I just wanted to show what we do. Every day we generate a report which tells us what our scores are, what our speed is. If anything goes up or down, we get notified about it and we do something about it. It's very, very important to us. So setting up something like this is really pretty simple. You could have it send something in Slack, an email, a text message, whatever you like. Call or send a phone call to your tech lead, maybe. They always like that. Clippy. Who knows Clippy? Yeah? All right. But half of you are old enough to remember it, and half of you are not. So Clippy came with like Microsoft Word or something like that, right? I'm remembering that right? It was like whenever you were doing something or typing something or like clicking on like file or whatever, this Clippy would pop up and go, hey, I think I can help you. I think you're trying to do this. It was always, always wrong. You were never trying to do what you wanted it to do. It would never go away. Even when you shut down Word, it would still keep popping up. Now, Clippy, in my mind, is a bit like a PWA, a progressive web app. It's like you go, I need this. And Clippy goes, oh, yeah, I knew you would need that. So I already got it for you. Here it is. You go, Clippy, I was thinking about this. Clippy goes, I knew you were going to think about that. So I already went and had a look. I did some reading, and I've got the answer for you. So PWAs, progressive web apps, if we break down the sort of understanding about that, that's like a web app. It's an actual app that they want to feed via the web, and they want to progressively let you build it up. So your first exposure to it is minimal. It probably won't even ask you to install the PWA the very first time, because it wants to be confident you're going to keep coming back and make use of it. So that's built into the system. It'll probably be the second or maybe even the third time you visit that URL where it'll say, cool, now I'm pretty sure you might want to install me as a PWA, as a progressive web app, and then it'll present that dialog to you. So PWAs are built on the they're built on the foundations of service workers. If you went and looked up the definition of service workers, it would probably somewhat rightly say a service worker in the context of a PWA is a programmable network proxy, which means that you can tell it to intercept network requests and do certain things, right? That is one accurate way of looking at it, but it's really not the full picture. A service worker allows you to run JavaScript outside of the context of the browser, okay? Let that sink in. That's really, really, really big, right? Node lets us run JavaScript in the context of a backend server. PWAs let us do all that anywhere on someone's machine. For example, mining Bitcoin. If you wanted all your users to mine Bitcoin, just create a PWA. They'll never know a thing. PWAs let you come up with a fetching strategy. So when your browser is trying to fetch certain resources or pages, the PWA can intercept that and say, I've already got it for you, or here it is. Or if it doesn't have it, when you get it, it'll store it. So next time you want it, it doesn't have to go look for it again. It'll present what it has to you, and then in the background, it will go and it will see if there's been an update, if anything's changed, and then present you with that new version. So it's meant to give you offline capabilities, basically. Oh, which is what it says there. So now the whole dating scene is not like working out very well for you. It's too free and loose. You don't know what you're doing. You're lost. You're confused. You're just not very good. So you join this dating club where they go, you can come to the club. You can order your food. We will bring your starters 15 minutes into your meal. Exactly 35 minutes into your meal, you will get your mains. And 20 minutes after that, you will get your dessert. And then you will go home. End of story. You will get your preferred partner. You will go through all this and that. Your waiter will be great. Blah, 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 blah. Everything is very nicely created for you. It's like a different version of dating. It's a little bit like AMP. AMP, who here has used AMP before? Okay, a few people. Not many. So what is AMP? Who here knows nothing about AMP? Okay, excellent. Most people know something about AMP. AMP is a Google technology, accelerated mobile pages. I can see a lot of people smiling now. This is a thing that if you Googled what is if you Googled AMP, you start typing, it'll probably auto-fill in, why is AMP evil? I hate AMP. AMP is the worst. I hate Google. So on and so on and so forth. There's a lot of people who really don't like it. Some people don't like it for what it is. Some people don't like it because it's Google. But what is it exactly? So, sorry, let me just go back one slide for a sec to sort of explain this. So what is AMP? AMP is a little bit like, I guess, like web components, a little bit. It's a little bit like, it combines two things. It combines Google's own JavaScript, and it combines a really strict way of building your page and building those components. You can use Google's own components to build your page. What they intend is to, well, their logo is fast by default. They're really concerned about speed and performance. They think we have a problem with the web, which we kind of probably do, and they're trying to fix it. This is their way of fixing it. They're saying, you use our stuff, it's super, super, super fast. Everyone's going to love it. Now, what are the sort of end results of that? If you use AMP, you could be displayed in that AMP carousel at the top. Until it was pointed out to me, I didn't even know it was there. But if you're doing a Google search on a mobile device and you see that little lightning bolt icon next to the name, that means it's an AMP page. It's a tiny little thing. That means if you click on that button, on that link, sorry, it's going to promise you you're going to get a super instant experience, like super fast, light years ahead of anything else that could possibly be downloaded. So you get displayed a little bit higher. You might get a little bit of SEO boost. Maybe it's kind of like a little bit here, a little bit there. You will get cached. Your pages are now cached. If it's a valid AMP page, it's now cached on Google's CDN. This is a part of the magic. This is a part of what makes it so quick. It does load almost instantly. You could, I did have an image here. I decided not to show it because it compares one of our pages with one of our competitors' pages, and I just didn't want to do that. But basically, if you went to a website, a regular website, non-AMP website, it might take a few seconds, 5 seconds, 10 seconds. If you went to, on that same device, on that same connection, you went to the identical same payload on an AMP page, it would take maybe 1/10 of a second, 1/4 of a second. It's as quick as you can get it to be. You wouldn't believe how quick it loads and becomes interactive. So why is that? What is actually going on? Because they have written JavaScript to build all these components. Well, it's open source. Has anyone looked at the open source AMP code or contributed to it? Okay, I have, and it's pretty cool. I enjoy it. It's one of many things I like using. And their JavaScript is good. It's really, really good. Some of the best engineers in the world collaborate on it. There's 500 open source collaborators that collaborate on it, but that doesn't make it like load instantly. That doesn't make it good enough to like load in like 1/10 of a second. So that's not what it is. So what really is it? Well, what's happening is when you're in your mobile going to do a Google search about something, car insurance, and then you see, oh, look, compare the market to car insurance. That looks good. I like meerkats. Maybe I'll get me some 2-for-1 movies. I'll click on that. Now, in that time you spent thinking about that, Google has examined that page, and it knows which one of those are AMP pages. And what it does is it prefetches those pages in the background on your device. So when you actually click on it, it has all those files cached, and it seems instant to you. But that's the magic and trickery that's going on behind the scenes. Now, underhanded, somehow wrong, annexing the internet, whatever you want to call it, bypassing all of the World Wide Web Commission sort of rules, having no oversight or anyone else having involvement on this, and just sort of doing your own thing. Those are some of the complaints that people have, and they're right. And then on the other hand, you have, well, as far as the user is concerned, they don't care whether it's Google, they don't care whether it's AMP, they don't care whatever it is. All they know is they went to X site and it took 20 seconds to load. Then they went to Y site and it took like half a second. So they like think, oh my God, this site is so much better. It's giving people a better user experience. So like it or not, it's almost certainly here to stay. We were at AmpConf a few months ago. I just want to say for the record, I'm not a Google fanboy. I'm not an AMP fanboy. It's a tool. Our team use it extensively because it solves our need. It's the right tool for our purpose. It's very fast. We are the gatekeepers to all of the money-saving products that our company offers. We want our product to be up and center when people search for stuff. We want, when people click on our links, it's instant. We make it easy and fast. We want to give them assurance that they're going to get a great service. That's why this is the right tool for our situation. So the downsides, and there's lots of them, you can have no custom authored JavaScript of your own in the page. They want to know where everything is. They want to know where every element is, where every image is. They want control of the loading of that page. They will not let you block the loading of that page under any circumstance, because they want to provide users with a consistently fast experience. You're also limited to 50 kilobytes of CSS in one single custom style tag at the top of your page. There are other restrictions as well. No inline styles, potentially render blocking elements like images. You can't just use your standard HTML image tag. You've got to use the AMP image tag, which intelligently fetches the right image, knows how big things are. You've got to play by all the rules. But if you can, you know, there's plus sides. But what's coming in the future of AMP? Now, this is one of the emergent, game-changing sort of question mark technologies that I talked about in the beginning. So there is an open issue to discuss putting JavaScript into AMP now, because it's the one thing that most developers complain about. I love the front end. I like JavaScript. I love AMP. I hate that I can't write JavaScript in AMP. You know, that's my passion and love. I want to write JavaScript, and so do many, many other developers. So that's why they are now considering a way to allow us to write JavaScript in AMP. And their proposal is that it will maybe be in something like Preact, a small version of React, and it will almost certainly be off main thread, which means they will not allow us to block that page, but they will say, okay, that's cool. You can still do stuff with JavaScript, but it'll have to load later. Just as an aside, we can actually get around all those restrictions just by using iframe. So there, oh no. Oh no. Pwamp. The name is ridiculous, but it's kind of a cool thing. It kind of works. That's a progressive web AMP. That is an AMP page that will transmogrify into a progressive web app. And the way they let you do that is with an actual AMP component called AMP install service worker. So we can't install a service worker. We can't write our own JavaScript, but they've given us a way that we can download our own custom service worker and then have a PWAMP and then do whatever you want. We've not used PWAMPs ourselves. They're kind of interesting. I'm really, really scared of progressive web apps. I'm really, really scared of service workers. I can't predictably see and monitor what they're doing. I'm a little bit frightened at the level that we're using it at. So we haven't really gone so much into these service workers, but it's a very cool technology. It's not super, super mature yet, but it's definitely come out of its sort of teething stage, I think, and it's in a decent place if it's something useful for you. And that there in the left, that's like a typical snippet you'd have to put in your code to load your custom service worker. Now, none of the above is working out for you when you're dating. So you go and read some books. You want to like figure out what are the secrets. Look at this guy, online dating wingman. This guy's a winner, right? This guy's going to teach you everything you need to know. It's in that self-help section where we go to experts to ask for advice. Yeah. What do you know? You must be successful. Look at your awesome jacket there. You know, you must be killing it. Tell me how to be an online dating like aficionado. This is something I want to talk about. This is this kind of expert culture where I'll be sat there. Sometimes you'll be stood here. Sometimes I'm stood here. I'm sat there. I'm sat there a lot of the times. And you're looking to experts sort of tell you stuff, you know, use React for everything. AMP is the future. AMP is evil. TypeScript. Docker. Am I right? Docker. Yeah. These are the kinds of things that sort of people tell us to do, tell us to use. Now, you're sat there thinking, I probably know what I'm talking about, right? The more dangerous part is that people stand up here and we think we know what we're talking about. We kind of do to an extent. We have some information, we have some knowledge. I've tried to present stuff to you that we ourselves have used successfully in production, so I know it's a safe bet. But I've learned so much from a lot of pain to really question what people are saying, what advice people are giving us, because it's really easy. We want to do the right thing. I mean, I probably have given you some bad advice tonight, not because I wanted to, because I wanted to give you really great advice, but I'm not perfect. Maybe I'm wrong. Maybe it's the wrong advice for your situation. Maybe it's not for your code base. I can't really predict that. There's a lot of variables here. So one specific instance I want to call out is maybe around a year ago or so, I was learning React. I was really fortunate to have a couple of great teachers on my team who were brought on to train a few of us up. And at that time, I was doing a lot of playing around and reading myself. And a lot of people were like recommending like inline styles and stuff. And I was like, man, I really, really do not like inline styles. Like if you look at this button here, it's a really, really simple button. This is what the markup should look like below it. And if we put in inline styles, that is what it would look like. I mean, that's massively bloating the DOM. This is so hard to work with. Everything I was reading was saying, React, inline styles, yeah, beautiful, great. So I was like, well, that sounds horrible to me. Why would I want to do that? And then my teachers were telling me to do that as well. And I was like, that's really not a good idea. And then I did a bit of reading when I was writing a blog that I'm just going to tell you about. And in a benchmark, they took a typical page and then they transferred all of the styling to be inline. And that caused really, really massive performance drains. The DOM quadrupled in size, took twice as long to mount, 50% longer to become responsive. The browser does not like CSS objects and JavaScript objects just inserted willy-nilly into the DOM. It finds it really, really hard to parse and compute those things. So in conclusion, that was optimization. I've tried to give you like a really, really broad sort of overview of everything because like the way I apply optimization in my work is usually by like several passes. You do like okay, this is probably a good way to do it. And then you get a little bit more deeper and you try to understand, well, actually, there might be these complications. So you need to be armed with a lot of knowledge to make the right decisions. I've written a blog about this. If you do want to go find it, it's right here. And that was me, optimizing the web like I was dating. Tweet me if you want to know anything. That's it. Thank you.